Hello everyone, I'm Makazani from Stroud Research Center. Today I will go through the step-by-step process of entering data into the discharge rating curve calculator. This will be part 2 of 2. Part 1 focused on inputting data collected from a flow meter. Part 2 will focus on inputting data collected from a neutral buoyant object. You will notice a lot of text on all sheets within the calculator as we work through the step-by-step process. This text provides more detailed instruction as well as notes on any issues that may occur while working within the discharge rating curve calculator. Please refer to them if you need any detailed clarification. When first opening the discharge rating curve calculator, you will be placed on the instruction sheet within the Excel workbook. There will be a yellow bar at the top with a security warning. Hit the Enable Content button. This allows the program in the calculator to function properly, and without it you won't be able to add future storm data. Make sure to hit yes when they ask if you want to make this file a trusted document. Click on the Rating Curve tab at the bottom to move on to the next step. On the rating curve sheet, you will notice a blank chart where the rating curve will visually develop over time as you add more storm data. Above that, in green text, is where the rating curve equation will develop as well. Above that, in a small box in green text, is where your staff gauge to sensor depth offset will develop as well. To the right of everything is space for a data table that will automatically build as we add more storm events over time. To add your first storm event, scroll back to the left and click on the gray rectangle labeled Add a New Discharge Measurement. A pop-up will show up asking for approval to build the Excel sheet. Answer yes to all the pop-ups for the sheet to be built correctly. You will automatically be taken to a blank storm event sheet. To add more sheets, just go back to the rating curve sheet by clicking on the tab below, and then hitting your gray button. You will then see all your pop-ups asking if you want the sheet built. Say yes to all of them in order for the sheet to be correctly built. Now we'll go back to our new blank discharge sheet and we'll add in all the basic metadata first. Be sure to include the names of everyone who was present when you did the discharge measurement. Now be sure to enter all your location data, including stream name, location description, site ID, and Latin long. Now add the date and time of when you took the discharge. Be sure the times are entered in as EST and not EDT. Next, add in your staff gauge height, your sensor depth, and the offset between the two. Since we're using a neutral buoyant object in this scenario, you do not have to enter in your velocity meter name or the calibration date. Next, we'll scroll to the right, past the cross-section and velocity measurements table until we reach the alternative data inputs section. So we'll bypass this table since this is only for flow meter, and we'll use this column right here labeled neutral buoyant object measurement under the alternative data points section. To begin, we'll first enter our distance data. This will be found on your stream discharge data sheet. Then we'll enter in the times that were recorded on the data sheet. And finally, we'll enter our predicted wetted cross-sectional area. We'll go through a few steps to get this number. We'll start by going to the staged area predictor for this site. This video assumes that you've already set up your staged area predictor for this corresponding site. If you just open a new blank calculator, please refer to the separate staged area predictor video to properly set it up. You want to go to the staged area tab at the bottom and then enter in two ways. You can either enter in your staff gauge height at the time that you measure the discharge with your neutral buoyant object, or you can enter in the recorded sensor depth at the time that you use the neutral buoyant object, as well as your average sensor to stage offset. Either one will give you your predicted wetted cross-sectional area. We'll use the staff gauge height for this scenario. We'll then take this number and we'll plug it back into our discharge calculator right here. We'll double check to make sure it's the correct number. And it'll produce a discharge. Return to the rating curve sheet of the discharge calculator to see how your new discharge was plotted. You'll first take notice that a new set of points has been plotted on your chart within the rating curve sheet. The rating curve equation will not have changed since we only have one set of points, but as you add two or more sets of points on here, this will be modified in conjunction with what's going on here. The same can be said about your offset. It will average out over time as more points are plotted. If for some reason there's a set of points you need deleted or want to delete, you can do the following. You'll first want to delete your discharge event down here that you want to get rid of by right-clicking it and hitting delete. And hitting delete when a pop-up comes up. Then scroll over and you'll have to delete the line that corresponded with that discharge event in here to get rid of your reference issues. In order to do that, you'll want to unprotect the sheet on your rating curve sheet, highlight the line that has the reference issues, right click, and choose delete in this box. Make sure the Shift Cells Up option is selected and hit OK. It will then delete it. If you have more than one line, unlike me, if there's multiple lines, you'll then want to add in your border again for it to look proper. Choose a thick box border when you do so. In my case, the only thing I would need to do is hit Review and then reprotect the sheet. I'll make sure that the Select Unlocked cells is chosen and hit OK. This concludes my talk on how to enter data into the discharge rating curve calculator with data from a neutral buoyant object. As said before, this is part 2 of 2. Part 1 focuses on entering data collected from using a flow meter in the field. Thank you for watching. I'm Matt Gazzani from Stroud Water Research Center.